Hello, my name is Andrew Silliphant and I am a Principal Solutions Manager with Pure Storage. Today I'm going to talk to you about databases and volume snapshots and where volume snapshots can be used with databases. FlashArray volume snapshots are created as a reference to the contents of a volume at a point in time. They can be created, copied, or restored instantaneously. They are also thin provisioned and deduplicated so that they do not consume any more space than is absolutely necessary. Volume snapshots can also be created on their own for a single volume or as part of a protection group containing many volumes, ensuring that all volumes in that protection group are consistent with each other at each point in time. This is really important for databases that could potentially be sharded, such as SAP HANA with its scale-out technology capabilities, ensuring that each and every single node or replica is consistent with each and every single piece of storage at each point in time. Volume snapshots can also be created using our Safe Mode Snapshots technology. Safe Mode Snapshots allow us to ensure that no volume is eradicated before the point in time that a customer sets this to be. Volume snapshots for databases can be created in one of two different ways: crash consistently or application consistently. A crash consistent volume snapshot for a database volume is only done at the volume level. What this means is there is no quiescing, there is no state of preparedness for the database volume. It is assumed that the state in which the volume snapshot was created is the state in which the database will be restored. Sometimes this is as simple as equating it to pulling the plug on an entire database and then powering everything back up. Application consistent snapshots are a lot more involved. What this means is that there's coordination between the creation of the volume snapshot and the application. This could involve quiescing at the application level or ensuring the database is in a specific state of preparedness in order to create that volume snapshot. So let's begin with the volume. This is our volume on a FlashArray. This volume is both thin provisioned and deduplicated. To create a volume snapshot is easy. You either execute the command via the CLI, the graphical user interface, or any of our REST APIs. And immediately, as soon as that volume snapshot is created, it is present as an immutable copy of the volume for that point in time. Now, once your volume snapshot has been created, we can actually do one of two things. We can restore it to a new volume, creating a copy of the database at that point in time and ensuring that its contents reflect how it was when we started creating it. Or you can restore the volume snapshot to its original volume, overwriting its contents. Now this is important. Even though you're overwriting its contents, you're not losing the state of those contents prior to it being overwritten. All that happens is we actually just create a snapshot of that volume prior to changing its state to this volume snapshot, thus ensuring that you have yet another volume snapshot you can restore things to should things go very badly. Let's move on as to how these unique snapshot capabilities can be used for different databases. What I've done is I've drawn up a list of some of the most popular databases on the planet. Microsoft SQL, Oracle Database, SAP HANA, MySQL and MariaDB, Postgres, and MongoDB. MySQL and MariaDB will share a lot of the same use cases, so I'll only be drawing up the use cases for MySQL, even though they apply to MariaDB. Let's take a look at the first use case, which is data protection. Each and every single one of these databases can use data protection. Microsoft SQL can have volume snapshots created application consistently using the VSS provider or the SQL Server Management Studio extension. It is also possible in SQL Server 2022 to create VDI-based snapshots, thus eliminating the need to use VSS. Oracle Database snapshots can be created application consistently or crash consistently. If we use crash consistent volume snapshots with Oracle Database, all this means is that Oracle will start up as if a power cord has been pulled from the server. SAP HANA is a lot more complex, but you can create both crash consistent and application consistent storage snapshots. With SAP HANA, the process to creating an application consistent snapshot is called creating a data snapshot. Creating a data snapshot simply writes all of the instance information to a specific area on the data volume and ensures that during recovery, it knows how to recover that specific instance. With regards to crash consistent snapshots with SAP HANA, all that needs to happen is mount up the volume to the SAP HANA instance, ensure that it's mounted at the correct location, start the instance, and it will come up as if it was rebooted or a power cable has been pulled. With a scale-out SAP HANA system, you need to ensure that each and every single volume is mounted to the correct node from whence it was taken. With MySQL and MariaDB, because there are a numerous number of storage engines that could be used for these, what we're going to do is we're going to focus on the most popular storage engine, which is InnoDB. And what we're going to do is talk about how that storage engine can be used to create application consistent snapshots. Whereas if you are not using InnoDB, simply just create crash consistent snapshots. So with MySQL and MariaDB, you have the ability to close and open the storage engines and put them into read-only mode. Specifically to InnoDB, that's a single command. To create an application consistent snapshot, all we do is we execute that command, wait for it to come back, create the volume snapshot, and release the read lock. That's actually really easy. With Postgres, there's also a way to do application consistent snapshots, and crash consistent snapshots work perfectly fine with it as well. MongoDB can also create application consistent snapshots or crash consistent snapshots and require you to have either CLI or API access to the instance. The next use case we're going to talk about is how databases achieve scale. With Microsoft SQL Server, what we have is we have a technology called always-on availability groups. Always-on availability groups allow SQL Server environments to scale by replicating the data from one instance to another for a specific database or databases. What's really important is that when that data is being copied from one instance to another, that's going to take time. Volume snapshots can be used in this instance to speed that up significantly. From SQL Server 2022 and onwards, this even becomes a process that can be done online. Whereas in previous versions of SQL Server, availability groups need to be seeded in an offline mode. For Oracle databases, there's a technology called DataGuard or Active DataGuard, which creates a physical standby server for disaster recovery and availability purposes, as well as ReadScale for Active DataGuard, which is a licensed feature. Now, volume snapshots can be used to create the physical standby prior to ensuring it comes online and doing the configuration. This saves a hell of a lot of time during the seeding process of setting up that physical standby server, thus eliminating the need to use RMAN or any other backup or recovery capabilities. For MySQL and MariaDB, there are a number of replication technologies, starting with standard replication, then moving on to group replication for MySQL, or Galera cluster for both MySQL and MariaDB. In every single one of those replication technologies, volume snapshots can be used to seed the replicas or secondary systems. For all of the replication technologies within Postgres, volume snapshots can also be used. This is true for log shipping and streaming replication. For MongoDB databases using replica sets, any replica can be seeded from one specific available system. The final use case for volume snapshots with databases is making application workflows more efficient. Application workflows can include things such as taking a production system, copying it to a different place, doing some bits to it, and ensuring your developers can use it for live test and development. It's also possible to use it for quality assurance purposes, ensuring that if we need to run specific reports, but we don't want to overload core systems or production systems. The use of volume snapshots with databases can replace slower tools, thus increasing the efficiency of all of these workflows. Thus, for every single database on this list, as well as others, if you want to do ETL, if you want to do test dev cloning, you want to do QA cloning, or you just want to spin up an additional replica, every single one of these use cases is possible. FlashArray volume snapshots are a fantastic tool to accelerate business processes. They are highly efficient, can be used for data protection, increasing overall scale or as a part of increasing overall scale, as well as application workflow management or orchestration. What's really important to note is that through all of these use cases, this is just a single data service included within FlashArray or Cloud Block Store, but is also highly efficient in terms of reducing cost as volumes are initially deduplicated, volume snapshots only point towards changes in the original volume, thus conserving as much space. Volume snapshots are also compressed and deduplicated, as well as instantaneous copies are not going to consume more space than is needed at all. This allows you to streamline application business processes. It allows you to focus on what is most important to running your business.